All right, let's dive right into this explainer. Picture this. The year is 1912. The RMS Titanic, which everyone famously called the unsinkable ship, meets a really tragic end in the freezing, pitch-black waters of the Atlantic, about 700 kilometers off the coast of Newfoundland. Out of the 2,240 people on board, roughly 1,500 lost their lives. And for decades, pretty much everything we knew about that night came exclusively from the traumatized survivors. These were eyewitnesses frantically fighting for their own survival in freezing water, just trying to process the sheer scale of the disaster happening right in front of them. Since the first rescue ship, the Carpathia, didn't actually show up until an hour and a half after the Titanic went under, there was absolutely no objective record of the physical sinking. We just had those panicked memories. And as we're going to see today through some seriously incredible modern data, it's a huge reminder for us. Human memory under extreme trauma is incredibly unreliable, and it doesn't always line up with scientific reality.
So here's the thing that really gets you wondering. It's this major, glaring anomaly. Why on earth were the two halves of the ship found a massive 2,000 feet apart on the ocean floor? And it gets weirder. Investigators noticed that the front part of the ship, the bow, was actually in pretty decent shape considering it had been sitting in the deep sea for decades. But the back half, the stern, it was completely and utterly obliterated. If the whole ship was made out of the exact same steel, hit the exact same iceberg, and sank at the exact same time, this huge difference in how they looked and where they landed just didn't make any sense. It immediately tipped off modern researchers that something else, something way beyond just the iceberg strike, happened to that stern on its way down.
Which brings us to Section 1, the iceberg strike myth. We're looking at 1912 eyewitness accounts versus modern science.
Now this is where the story kind of flips on its head from what you might have learned in history class. For decades, the accepted truth was that the iceberg ripped this massive 300-foot continuous tear along the side of the Titanic, taking out roughly a third of the ship's side. But when modern explorers, like the late, renowned ocean explorer P.H. Nargeolet, who visited the wreck over 30 times, used high-tech 3D sonar to look through all that mud and rust, they found absolutely zero evidence of a 300-foot gash. Instead, what they found was just a series of small, narrow fractures stretching across 30 feet. When you actually add up the open space letting water in, a mere 11 square feet. It is honestly mind-boggling that a hole roughly the size of your kitchen refrigerator door took down the most famous supership in history.
And this perfectly illustrates a massive physics paradox that investigators had totally overlooked for years. See, eyewitnesses universally agree that it took the Titanic exactly 2.5 hours to sink after it hit the iceberg. But if a ship of that massive size actually suffered a 300-foot gaping hole in its side, physics tells us it absolutely would not have taken 2.5 hours to sink. It would have flooded instantly and gone down in mere minutes. The historical timeline completely contradicted the historical damage report.
So let's actually do the math here, because this is fascinating. Using the modern discovery of that tiny 11 square foot crack, engineers calculated the water pressure and inflow. The result? Exactly 370 gallons of water pouring into the ship every single second. Now, when you calculate how long it takes 370 gallons a second to fill the internal volume of the Titanic up to the point of sinking, the math yields a time of exactly 2.5 hours. It perfectly aligns with the survivor accounts of the timeline. The mystery of the iceberg damage was finally solved not by old historical documents, but by modern fluid dynamics and sonar.
Moving on to Section 2, A Tale of Two Halves, the Deep Sea Mystery.
Think about the front of the ship for a second, the bow. It's totally hydrodynamic. Its entire design is meant to slice through water. So when it broke off and sank, it essentially just sailed its way down to the ocean floor, gliding relatively smoothly through the water column, which is what protected it from massive structural damage. The stern, though, completely different story. The back half of a ship is super blunt. It is definitely not designed to fall backwards or straight down through water. The 3D models show that its decks are completely pancaked, just collapsed into one another like the steel was made of flimsy paper. In fact, among the chaotic wreckage of the stern, pretty much only the two massive, house-sized engines remain stubbornly intact.
So what on earth caused this absolute obliteration of the stern? Well, the clue actually lies in impact marks left on the ocean floor over a century ago, which are only visible now through advanced 3D scanning. By analyzing these deep trenches in the mud, scientists uncovered a genuinely terrifying piece of data. The stern was hurtling toward the bottom at an astonishing 80 kilometers per hour. That is highway speed, straight down into the abyss, all while violently spinning in an anti-clockwise direction.
Just imagine this massive chunk of steel falling at 80 kilometers per hour. Because it was blunt, not hydrodynamic, and spinning anti-clockwise, the sheer hydraulic friction and water forces acting against it were just immense.
Long before it even hit the bottom, the water pressure was literally violently ripping off any loose parts, just tearing the outer shell away. Then, after falling for nearly 4 kilometers, it slammed into the ocean floor at that incredible speed. The kinetic energy of that impact instantly crushed the remaining steel decks down onto each other like a compressed accordion. So it wasn't just the rust that destroyed the stern over the decades, it was the catastrophic violence of its journey to the bottom.
All right, Section 3, the debris field clues. When did the ship actually split?
For absolute generations, the narrative, which, again, was based heavily on the eyewitness accounts of survivors sitting in those lifeboats, was that the Titanic completely snapped into 2 entirely independent pieces while still bobbing right there on the ocean's surface. They saw the stern rise high into the air, heard a terrifying crack, and assumed it broke clean in half up top. But does the physical evidence at the bottom of the sea actually support this?
Down there, scattered across the ocean floor, you've got over 10,000 individual items. And we're talking about deeply personal and daily objects here. Coffee cups, fine dining plates, luxurious chandeliers, personal luggage. And here is the incredible irony. Super fragile things like coffee cups and plates survived the journey, while the thick steel hull did not. But when researchers mapped and categorized this massive field of artifacts, they found something really shocking. 90% of the items scattered in this field belonged exclusively to the stern section of the ship. Only a tiny fraction came from anywhere else on the vessel.
And honestly, here's the absolute nail in the coffin for that whole surface split theory. The entire debris field covers a really concentrated area of roughly 3.2 square kilometers. Experts point out a simple fact of ocean currents. If the stern had completely separated from the bow at the very surface of the ocean, spilling its contents right there, those teacups, plates, and suitcases would have fluttered down through 4 kilometers of moving ocean currents. By the time they reached the bottom, they would have been spread over a vastly wider area than just a tight 3.2 square kilometers.
So, here's what actually went down. First, the bow filled with water and began to pull downward, acting like a massive, unstoppable anchor. Second, this lever action lifted the stern high into the air, placing just an unimaginable, crushing weight right on the center pivot point of the ship's keel. Third, the ship did indeed break at the surface, which is exactly what the survivors heard. But crucially, it did not completely separate. The thick steel keel actually held on, partially connecting the two halves. The heavy bow dragged the stern deep underwater. It was only near the ocean floor, as those violent forces we talked about earlier really took hold, that the final complete separation occurred. The bow glided away, and the stern, spinning totally out of control, was violently shifted to its final resting place, 2,000 feet away, spilling its contents in a tight 3.2 square kilometer radius right before impact.
Which brings us to our final section, Titanic's final days, the microscopic threat. After sinking in 1912, the ship literally lay in total pitch-black darkness until it was finally discovered in 1985, 73 years later. Initially, scientists thought the wreck would be preserved for centuries, mainly because the oxygen levels at that extreme depth are incredibly low, meaning standard rusting happens very slowly. But nature found a way. A unique species of iron-eating bacteria has completely colonized the ship. And get this, these microscopic organisms actually release their own oxygen as a byproduct of consuming the steel, which rapidly accelerates the decay. We're at a point right now where these bacteria are eating away hundreds of pounds of iron every single day. In the very near future, the walls are going to become so thin that they'll simply give way, resulting in the total structural collapse of all the remaining floors. Basically, this means our generation is more than likely the last one that will ever get to see the Titanic intact.
And that brings us to a final, pretty profound realization. The unsinkable ship survived the massive iceberg, but it won't survive the microscopic bacteria of the ocean floor. It's definitely a sobering thought to take away from this explainer. The Titanic was the absolute pinnacle of human engineering, this massive fortress of steel brought down by a fateful iceberg. We've used our most advanced robotics and 3D modeling to finally figure out the violent physics of its demise. Yet, in the end, it's not going to be the sheer force of the ocean or that dramatic 80-kilometer-per-hour impact that ultimately erases the Titanic from existence. It's going to be the quiet, relentless appetite of nature's smallest organisms. So what does it say about our grandest creations when they are ultimately reclaimed not by disaster, but by biology? Thank you so much for exploring this fascinating data with me. And hey, always keep questioning what you think you know.